Okay, so this section is on how to find the area under a curve. Now, if we look at this first example, this one's actually not too challenging because since the function is a straight line, the area that's created is actually a trapezoid, and we have a formula for that. So you have to use a little bit of your geometry skills to find the height and the bases, as shown in the blue and the purple, and then to find the area of that shaded region, which is just the area of a trapezoid, you'll use the area formula, which is 1/2 base 1 plus base 2 times the height. So when you plug those numbers in, you get an area for that green shaded region as 7 units squared. But the problem is sometimes the function will not create a shape we have a formula for. So what we're going to do is we're going to put rectangles under the curve and then either use the left endpoint, right endpoint, or midpoint method to find the areas. So a couple things. More rectangles is going to be a better approximation. And the midpoint method we will find out is the best method because it kind of cancels out the over approximations, which this one has, because we can see these little tiny areas up here that we're counting that we shouldn't, or the under approximations like we see here, this little kind of triangle looking shape that's there that's not getting counted. So essentially the midpoint method will have a little bit over and a little bit under for each rectangle, and those kind of cancel each other out. So let's look at some examples. We're going to look at the same function 3 different times. The first one is f of x equals x squared plus 1, and we're looking at it from 1 to 3 using 2 rectangles in the left endpoint method. When you use the left endpoint method, you'll start with your point on the far left, which in this case is A, 1, and you will use the height of that rectangle by finding f of 1, which is 2. And then to find the area of the second rectangle, you're going to do f of 2, which is 5. Now, to find the base of the rectangles, you're going to use this formula every time. B minus A divided by the number of rectangles. So in this case, the base would be 1. So when you start at 1 and you add 1, you get 2. And when you add 1, you get 3. So the area is going to be 1 times 2, which is the area of the first rectangle, plus 1 times 5, the area of the second rectangle. Or a nice little formula is to take the base times the sum of the heights. And we get 7, which is clearly an under approximation because we're not counting those 2 little areas. Now, if we add more rectangles and use the right endpoint method, we first of all will find the base, which is b minus a over the number of rectangles. So that base is 1/2. Then to find the heights of the rectangles, we're going to start on the right side. So we will start with 3, and then we will subtract the base, which is 1/2, which takes us to 2.5, or 5/2. Minus 1/2 takes us to 2, minus 1/2 takes us to 3/2. So those will be the heights of those 4 rectangles, which will then plug into the formula base times the sum of the heights and get 51/4, which is an over approximation because we've got these little tiny, almost look like triangles, they're not quite triangles, that are getting counted that shouldn't be. So a better approximation would be the midpoint method. So looking at this one, we're going to take x squared plus 1 again, the function, and we're going to look from 1 to 3 again, but this time we're going to use 4 rectangles in the midpoint method. The midpoint method is a little bit harder to understand. So we first of all will find the base the way we always have been, b minus a over the number of rectangles, which is 1/2. However, to find the heights of the functions, we have to consider 1 plus 1/2 is 1.5. Now if we're using the midpoint, we need to find the midpoint between 1 and 1.5, which would be 1.25. Then we plug that into our function and we get 2.5625. Notice normally I would use fractions, but I thought for an example it might be better to show you with decimals. So then we're going to do the same thing. Once we get the first height, which is f of 1.25, we're going to add 1/2 to each one and then take f of those numbers and get those heights. Then we take the base times the sum of the heights and we get 85/8. So for your homework, I'd like you to try the following 4 problems and get those into me by 11:59 tonight. Let me know which ones you would like to see tomorrow. Good luck.